All right, so we're gonna start off with section 3.5a. Notice it says radical review on your worksheet and solving quadratics by square roots. So I know that we've been solving by factoring, but some of these problems can actually be done with square roots. All right. Number one, though, this is mostly notes. So I'm gonna give you guys these notes, or not notes, perfect squares. All right, so they want you to list the first 15. I always tell people, do the first 16. 16 usually is as high as they go. So 1 squared is 1, and 2 squared, right, 4. We have 3 squared is 9, 4 squared, 16, 5 squared is 25, 6 squared is 36. Now, they gave you a lot of space, by the way, so you're going to see why there's a lot of space. 7 squared is 49. 8 squared is 64. 9 squared, 81. 10 squared, 100. Most people know those. No problem, right? 11 squared, 121. 12 squared, 144. 13 squared, 169. 14 squared, 196, 15 squared, 225, and 16 squared is 256. Now I'm also going to write the square roots for them, okay? So that's why there's a lot of space. But first let me get some water. There's a lot of space that they gave you. They want you to know that, there are perfect squares, and these perfect squares, you can take square roots of them to get back the base number. So, to start off in order, the square root of 1 is 1. The square root of 4 is 2. Square root of 9, 3. Square root of 16 is 4. Square root of 25 is 5. The square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. And we'll continue up to 16. Okay, so a square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. 144 is 12. Square root of 169 is 13. 196 is 14. 225 becomes 15, and the square root of 256 is 16. So they want you guys to write those down. Again, this is review. This is not new. Excuse me, but not everybody knows all of those things. Okay, at least up to 16. A lot of people know up to 10, but not always up to 16. I know they put 15, but I always like going up to 16. So the rest of that worksheet in the front is they want you guys, actually up to number 10, is they want you guys to be able to break down radicals. Okay? So when you break down radicals, not every square root or radicals has a perfect square root. Right? So let me just give you an example of this. I'm going to move this down. Is that okay? Or up, I guess. So let me give you an example here. So we're just going to simplify. And we'll do the square root of 300. Now notice, I don't have a square root of 300 listed. Okay? But what I have to do is I have to break up 300 into a product of two numbers of which maybe one of them has a perfect square root to it. Okay? So I can break down 300 into 3 times 100. Okay, now don't write this down, but I also could have broken it down into 5 times 60. But the difference is, in 5 times 60, 5 does not have a square root, and 60 does not have a square root. Whereas if you look at 3 times 100, 3 doesn't, but 100 does, right? The square root of 100 is what? 10, right? So what I'm going to do is I'm going to get that 100 and bring it out. That's going to become a 10 radical 3. And that's my answer for that problem. Okay, 10 square root 3. The 3 doesn't come out, but the 100 can. All right, so that's how you do something like that. Now, other times, you might have something like the square root of 120. So now you got to start thinking, okay, what numbers can I use for 120? I mean, if I make a factor tree here, 1 times 120, 2 times 60, but notice 2 and 60, they don't have nice square roots. 3 and 40, but 3 and 40, they don't have nice square roots either. 4 and 30. 4 has a square root that's nice, so maybe I can use that. Okay. Let me keep going, see if I find anything else. So 5 times, what would that be? 2, 10, 20, 24. 5 and 24 don't have nice square roots. 6 and 20, none of those have nice square roots. And by the way, if you're saying, why do we keep going? We already found one. If we can find one dealing with bigger numbers, it's usually better than dealing with like a 4. If you can find one that's like at a 16 or something, that's great. But I don't know if we're going to have any. 7, does 8 go into that? Yeah. 8 times 15. But that doesn't work. And the last one, 10 times 12. So the only one that has a square root is right here. 4 times 30. So I'm going to write square root of 4 times 30. Well, I know the square root of 4 is 2, so I'm going to take that out. I'm going to rewrite the 30 in there, and we're done. So 2 radical 30. So you'll have stuff like that. Let me do another one of something similar to what you're going to see. Let's check out number 7. So negative 6 square root of 320. So 320, that's a big number. So let's try to think of any number that could help me out. Now I can start from 1 and 2 and 3 and 4, but instead of taking so much time, I know that 32 is 16 times 2, right? Like, so 32 right here, this number, 3, 2, and then I know there's a 0, but 32 is 16 times 2. So I know that 16 times 20 is one that works. Okay? Now there's actually a better number, but let's stick with that one right now. Okay? So let me write this as negative 6 square root of 16 times 20. Now 16 has a nice square root, right? That's a 4. So that's going to go out. Okay, so this is going to give me negative 6 times 4 square root of 20. I know I'm taking my time with this. I don't want to lose anybody here. So negative 6 times 4 is negative 24 square root of 20. Now, anytime you take a square root and you fix it, you always got to go back and check if you can reduce that other number anymore. Well, 20, I can actually rewrite it as well. 20 is 4 times 5, right? So let me get that square root and rewrite it as square root of 4 times 5. Now 4 does have a square root, okay? 4 has a square root of 2, so I'm going to take it out. So it's negative 24 times 2 square root of 5. 24 times 2 is 48, so negative 48 radical 5 is my final answer. That one, yeah, these are tougher, like the ones that have like really large numbers inside. Yeah, go ahead. So when they have really large numbers, you kind of have to start thinking like, okay, I don't want to list every factor because 320 has a lot of factors. But I can try to list a couple, and maybe one of these allows me to break it down, okay? The bigger the square root you can take, so like 16 was a pretty big number, the faster the process takes. Now you actually could have divided that by 48. That would have worked, okay? Or something else. Actually, not 48. What am I thinking? 54. 54 would go into that. Okay, 5 times. So 54 times 5 and stuff. You'd be able to get stuff. But the idea is to break it down as much as you can, little by little. Okay? Now, just to show you, so notice you have like number 2 is 200, number 3 is 20, that's small, number 4 is 72, that's pretty small. But then once you get to 6 and 7, they're like 252, 320. Now, just really quick, number 10, I want to do this one for you guys, and then we're going to talk about how you solve with this stuff. Okay, and it's actually easier to do the solve. But let's look at number 10. So we got 10 plus 5 square root of 125 over 5. Now I want to just go over something with you guys. If you have a fraction like that, or minus, it could be a plus or a minus, you can always split it apart. Like that. That's legal. You can do that. That's mathematically sound. Okay? So you can split it. So that's the first step I'm going to take. Let me split this up. 10 over 5 plus 5 radical 125 over 5. Now notice 10 divided by 5. That's 2. And over here the 5's will cancel. So you just have square root of 125. So we kind of simplify it first. Okay? Now the square root of 125, let me do this over here like scratch work. 125. That's 5 times 25. That's 125. 5 times 25. This 25 can go out. So that would be 5 radical 5. So let me get that 5 radical 5, and I'm going to put it in my problem. So 2 plus 5 radical 5. And this is your answer. I always get people who add 2 plus 5, they write 7 radical 5. Okay? But you can't combine them unless they have the same square root. So in other words, if you had like 3 radical 2 plus 5 radical 2, that is 8 radical 2. That is true. But 3 plus 5 radical 2 is not 8 radical 2. Because this one right here doesn't have a radical 2 with it, or square root of 2. They need to be like terms. So that's how you would do 10, okay? The rest of these, I'll let you guys try to work them out. Now, 11 through 16, let me do 2 of these for you guys, okay? Hopefully we have time. Yeah, we do. Okay. So, I don't know. Let's look at number 15. We'll do a tough one, then we'll do an easier one. So, 64r squared plus 9 equals 18. So instead of solving this by factoring like you did yesterday, if you just have one variable that's squared, what you can do is move numbers around. So notice I'm going to subtract 9 first. So 64r squared equals 9. And then I'm going to divide by 64. I get r squared equals 9 over 64. And what you have to do at this point is, you see the r squared? We can get rid of it, you guys have seen this, by taking square roots. But anytime you take a square root, you should always have a positive and negative answer. So for my next step, it's going to be r equals plus or minus. Notice this fraction can be reduced. What's the square root of 9? And what's the square root of 64? So there you go. Those are your answers. So if you get a fraction, don't get scared. Just take a take a square root of the top, take a square root at the bottom, and that'll give you your answer. Oh, not number 16, I'm sorry. I'll let you guys try that one, but number, I don't know, let's try 14. So 25a squared equals 1. So I just want to get the squared term by itself, so I'm going to divide both sides by 25. So a squared is equal to 1 over 25. So if I take the square root of both sides, you're going to get a equal to plus or minus. What's the square root of 1? 1. What's the square root of 25? So it's 1/5 plus or minus 1/5. Okay? So that's how you do the problems in the back whenever you have to solve for a squared term. So I'll go ahead and let you guys work on that.